This video is a quick tutorial on central vacuum motors, their differences, and how you can tell them apart. And there's 6 major areas that we want to look at. The first is their diameter. The second is if they're metal or plastic. Third is if they're bypass or through-flow. Fourth is tangential or radial. Then we're going to look at number of stages and the voltage. The diameter of the motor is the easiest thing to determine. They come in various different diameters that is measured across the base of the motor. This would be a 5.7 inch. There's also a 6.6 inch, 7.2 inch, and 8.4 inch. In fact, some central vacuums recently have started to employ motors that are even smaller diameter. You want to match the new motor to the correct size if you're replacing a motor. The larger diameter motor allows for a slower speed to the motor to create more airflow than the smaller ones. The larger diameter motor gives a slower fan speed. They can slow down the motor even though the outside of the motor is spinning faster and gives a better performance from that. The motors can either come in a thermoplastic main platform housing or in a metal housing. Obviously the metal is going to last longer. It's designed for longevity. And this is available in the 5.7s and the 7.2s. Often you can exchange one motor for the other as long as all of the rest of the bolt configurations match the same. You can exchange a motor metal versus plastic. Also watch the cooling intake to make sure it's at the right height. I want to explain the difference between a through-flow motor and a bypass motor. A through-flow motor has the air come in through the intake of the motor blades here, and it comes through the motor. It relies upon that air to cool the motor. Obviously, it has to be dust-free, otherwise there would be dust all in this portion of the motor. Also, you can't not run this motor totally sealed. If you do, it will keep the motor from getting any cooling, and you're going to destroy that motor much faster than you really need to. If you use through-flow motors, we recommend using an air relief valve. That will let air come in if it's running on a sealed system. But we really recommend it below the filtering system rather than just in the piping system to make sure you're not going to hurt those motors. Bypass motors are slightly different. They bring the air in the motor, but it bypasses the motor. It doesn't come into the electronics of the motor. It bypasses and either comes out a radial exhaust here or a tangential. We'll talk about that in a second. That air is not coming through the motors. It has a separate cooling fan that draws cool air into it at all times. Cooling air comes in here and exhausts out the side of the motor. That separated system allows it to operate much more efficiently over time without burning up the motors. Also, you should never mix this air with the exhaust air out here. So there's usually a barrier that keeps this part of the motor from being exposed to the rest of the air from it. If you block the intake here, you won't hurt the motor at all. It will run and run and run without hurting the thing because it has its own separate airflow coming through here. And that can happen sometimes if you were to take a motor like this and mount it up high, like in a cyclonic unit up high, and there was no protection on the top of the tank. I've seen where boxes have been put on top of this motor. Well, if you block off this air intake, now you've lost your cooling air and it would damage the motor. You want to be careful of that. No cooling air, that motor is going to overheat. The advantage of this type of motor is you can run it for extended periods of time without an air relief valve. The next difference we want to look at is a tangential exhaust or a radial exhaust. With a tangential exhaust, the air comes into the motor, and rather than coming through the motor, it comes out the side in a horn or at a tangent to it. That is where all of the air comes out, and it has all the fine dust that may be in it if it has a poor filtering system. If you vent that, all of that air is gone. These motors, though, tend to be louder because you can't quiet them as much. The radial type, the air is coming around the entire radius of the motor. And this air doesn't flow through the electronics. It's much easier, though, to muffle this noise because it's coming out in all different directions. Next, we want to look at the number of stages that motors have. This would be a single-stage motor. If you look at the side of it, you'll see the fan structure here. There is one set of fans, 2 sets of fans, and 3 sets of fans. So it's 1, 2, and 3 stage motors. The air enters into one stage, and then it compresses the air and throws it out the exhaust. But if there's a second stage in it, there's actually a stationary fan inside of there, and it blows past that, and the second stage will actually build up the water lift. So as you go up in stages, you should be increasing in water lift. If we went to a 4th stage, there's a slight little problem in that shaft that has to drive that motor, it has to be really long. By the time you run it through there off the bearings, the slightest little bit of wobble is going to cause that motor to be imbalanced, and you're going to have motors go out far quicker. So generally, most manufacturers keep it to a 3-stage motor maximum. Most of North America runs off of 110 volt motors. That's pretty standard. 240 volt motors are often offered when there is just too much power requirements that would exceed the need for a 20 amp 110 volt circuit. So they would put maybe 2 motors would require larger than a 20 amp circuit. You could either go with a 30 amp or a 240 volt. The 240 volt motors look very, very similar to the 110. Your connections come in either direction. It doesn't matter polarity with either one of them. Also, if you're replacing a 110 volt motor, make sure you're replacing it with a 110 and a 240 with a 240. That's very important. Typically, the power between the 110 and the 240 volt is very, very similar. They're very alike on most motor configurations. Lastly, let's look at a few other things. The fan structure in the actual fan of the motor itself comes in 2 different ways. The standard way that we offer them is designed for motors that have a really clean airflow coming into them. There's not a bunch of debris. If you have a lot of debris, there's a non-loading fan that has a slightly different tip on the end of the fan blades to allow the air to knock any dust that might be coming on the motors. For the most part, you can exchange a non-loading for a standard loading fan structure in a motor. It's just going to be a longevity issue. Speaking of longevity, you can see these motor brushes are up here on the top, and they're about that long. There's a new motor out, the 8.4, that actually has curved motor brushes. They're considerably longer, and this motor will give you far longer life with the 8.4 inch. Over here, we have 2 different types of structures. You've noticed the side of this, it's conical shape. It comes in at an angle versus a flat motor. This is fairly new, and this style allows for a bigger fan inside of it to be able to provide more performance. We might call them more high-performance motors. If you're looking at an older motor, you can also tell usually there's a motor number either stamped or located on a date code piece here, and it shows the date when it was manufactured. For older ones, you'll find a green stamp somewhere on the base of the motor here, and it'll be digitized. The last 2 digits of that that's written in there in green is usually the year that it was made. We hope this short video has been a help to you to understand how central vacuum motors are different and how you can find the right motor for your needs. Thank you for watching MD Central Vacuum Motor Explanations.